Okay, I'll kick off. These are quite short talks, so I'll go straight on time. So I'm Steve Millidge. I'm the founder of Payara. I'm going to talk about cloud-native Jakarta EE, and I'm going to talk about a different approach for cloud-native that we're working at in Payara. So I'm going to take you through that. Okay, first, what is cloud-native? So this is a definition from InfoWorld, and essentially it's saying that this approach to running applications that exploit the advantages of a public cloud or cloud computing delivery model. And that delivery model is typically resources on demand, it is elastic, it is remote, and it is infrastructure as a service, essentially. We have another definition here, which is from the Cloud Native Computing Foundation. So the first sentence aligns with the InfoWorld one, in that it's about running scalable applications in public-private clouds. But then the second sentence all talks about containers, service meshes, microservices, immutable infrastructure, and that sort of capabilities that you get from some sort of public cloud infrastructure. However, that isn't necessarily cloud native. That is just a bunch of infrastructure technology that you have available to you to build applications and package them for public cloud or private cloud or internal Kubernetes or something like that. So I'm going to take you through Payara's thinking of a different approach to cloud native. So we start with, what is a Jakarta EE application? So fundamentally, in Jakarta EE, from the beginning of Java EE, we've had a definition of a package. So we've always separated the application from the infrastructure. So what you do as a developer in Java EE, Jakarta EE, is you take your application, you work on your business code, you then package it up with some dependencies that you may need, and you can create deployment descriptors if you need deployment descriptors nowadays. So you can use annotations or something like that. And that is, as a developer, what you really need to do. So essentially, you can concentrate on business code, package it up into a WAR file, and then you need to do something with that. And what you need to do is get it to run somewhere. So what is not in an application is all the other stuff. Okay, so this is provided by Payara, or any other application server vendor, or any other runtime. So from an application development point of view, the application server is providing you services. So it provides threading services, provides messaging services, metrics, data sources, security, all the other things that sort of cross-cutting concerns that as an application developer, business application developer, you may not want to be concerned about. And at the same token, then underneath that is a load of compute infrastructure. Now, compute infrastructure has changed hugely over the past 10 years. I mean, I would argue that the biggest revolution has been in the compute infrastructure layer rather than in Jakarta EE and in the Java layer. So, and what our job at Payara is to make your application run on different compute infrastructure. Now, there's a lot of advantages which people may have forgotten around separating your application from your runtime and your deployment. So first, foremost, you don't need to self-assemble your application runtime. So you take an application, you write business code, you put in your dependencies, and you package it up in a WAR file. What you don't need to do is then worry about all the other threading libraries, connection pools, and things like that to put together some sort of runtime for you. Now, people have done this quite a lot, especially if we in the past worked in early Spring and things like that. You would self-assemble a runtime And there's no need to do that with Jakarta EE. All the pieces in Payara are guaranteed to run together because we build them and certify them against the specifications. And that runtime obviously can be versioned. You know what runtime you've got. So the more dependencies you package into your EE or WAR, the more you don't really know, once it's gone live, what's in there. So, when people get things like log4shell things like that occur, people scramble around and start unpacking runtimes to see if that's there or not. Whereas the thinner your WAR can be, the less risk you have like that. And obviously, we provide security capabilities, monitoring capabilities, and all the other things that you want from a runtime. For example, if you're taking just a pure Jakarta EE application, then what we can do, in a similar way as what the JVM can do to a Java application, is we can put a layer of insights on top of that, or underneath you, sorry. So we can, as you deploy, deploying is a sort of unfavorable at the moment, but as you deploy, the application runtime can actually look at your code, understand it, and work out insights from that code, and start doing things like putting monitoring in place. The other thing we can do is use tracing. So, if you deploy an application, then we can put probes in that application during deployment. It could be, open tracing, or in the future, open telemetry, because we support MicroProfile. And as the runtime vendor, then you have a lot of opportunity to understand what's actually there. So, there's a number of models that you can do if you're then looking to deploy your application onto cloud. So, and I'll be talking about Payara Cloud, which I'll try and convince you is a different approach. So, you can take your application, you can package it up into a fat jar or a jar, and you can then run that using the Java command line. Or, and we'll see later, the steps that you need to do to get that running on a public cloud under sort of infrastructure that CNCF talks about, so containers, Kubernetes, that sort of infrastructure. Or you can take the application server model and take that WAR file and deploy it onto the cloud. So, and allow your runtime to manage a lot of the things it managed before, but also manage a lot of the infrastructure requirements for a public cloud. So it can manage a lot of the compute infrastructure as well, because in the same way that the JVM abstracts operating system complexity from you, application servers have always abstracted the complexities of distributed applications. So that includes clustering, networks, all the other things that application servers do. And we sort of took the approach that actually things like Kubernetes and containers are actually just sort of poor application servers. And you need to have a layer on top of them to abstract that away for you as a developer. So our model is we want you to deploy your application anywhere. So as a Jakarta EE developer, you should be concentrating on business logic, solving your business issues, not messing around with all this new mess that is underneath. So we have, an application package in a WAR file could actually run in many different ways. You could run it on a Raspberry Pi. You could take Payara Micro or some other, single instance runtime and run it on a very small device. In fact, probably all the application servers could probably, in this day and age, run on very small devices. Then we have the whole sort of spectrum of infrastructure you have to worry about, from from bare metal into container services like Docker, through to VMware, through Kubernetes, and through to public cloud. And as a Java EE developer, you shouldn't really have to worry about that. And there's things you can do in your application, and there's things that people probably don't really know about. in Java EE that enables some of these things. So the first, not totally Java EE, but in Payara and almost all the other application servers, we have MicroProfile. So MicroProfile is built specifications for public cloud. Well, cloud-native applications, cloud-native deployments. So the thing you need to do is first you need to externalize config. So, because you're going to move your application from different environments, packaged in a WAR file, and MicroProfile enables you as an API to externalize config. So you can inject config properties into different parts of your application. Those config properties can come from configuration sources, and those configuration sources can be provided by the runtime. So they can come from Kubernetes secrets, they could come from properties files, or they could come from some Vault on in Azure or AWS. So you need to externalize config. The second thing you need to consider is deployable resources. So everybody thinks that within Jakarta EE and Java EE was, and we see this a lot with our customers, is that they don't realize that they can package most things that you need to work with your application in your WAR file in this day and age. You don't need to go in the admin console. You don't need to create data sources. You can just package them up. So for example, at the top, we have a data source definition. That can just be an annotation. It can be in XML, in the web.xml. And that would create the data source you need. You don't need to go into your application server, admin consoles, and create application servers. Sorry, data sources. Similar for MDBs. So if you've got messaging systems, you can do it all through annotations. In Payara, you can use MicroProfile config to inject the correct values at deployment time, so you don't need to unpack and edit something to change the environment. So you can just use npconfig to replace deployable resources. And there's lots of deployable resources. So in Jakarta EE you can even deploy managed executive services, which is what I was talking about yesterday. And the vast majority are deployable. And more, as we build Jakarta EE out, then more of these things can be deployed. We also have health checks. So again, MicroProfile, you can put health. So what that does is actually the runtime can check on your application, see if it's healthy, and you can do that programmatically. And obviously, if you were doing that in Kubernetes, you can link that up into Kubernetes and have rules to restart things and configure that through using the MicroProfile API. And obviously, there are other MicroProfile APIs that enable more cloud-native applications. But we'll talk a little bit about platform engineering. So platform engineering is like, I apologize, I put a Gartner quote on the slide, but platform engineering is really about building a developer experience that essentially is trying to remove all the stuff that developers have been lumbered with in this day and age. And it's like the child of DevOps in that, partly it's splitting out Dev and Ops again, in that there's an ability to build a platform so developers can actually just concentrate on writing code and deploy to a platform. And we sort of took the concept of platform engineering, and actually Jakarta EE is ideal for this because we have that separation between application and runtime. It's built into the specifications. It's built into the original model from day one. Back in the 90s, someone obviously thought this was a good idea, and it still applies now in the 20s. And why this is important is because cloud native, from a developer perspective, is incredibly difficult, in the sense that if you're a Java developer, there's a lot of other stuff that you need to worry about. So to take a WAR file and get it deployed on Kubernetes, there's these things that you need to do. And someone's got to do them, either yourself or someone else is going to have to do it for you. So as a minimum, you need to, build a container image. So you're going to have to start with a Docker file. You have to build a container image. You could use one of ours, but surprisingly, people actually use the ones we provide, which I always thought people would build their Docker containers to their needs. So that always surprises me. And then you need to obviously layer on your application server, and then layer your WAR file on top of that. Then you need to create a pod. You need to learn YAML. You need to configure secrets. Then if you wanted to put it on, for example, Azure, then you need to get it into Kubernetes and get that definition into Kubernetes, set up VMs for the actual Kubernetes infrastructure, and then worry about API gateways and configuring SSL certificates and all that sort of thing. So we thought, if only there was an easier way to do this. And I'm going to show you that now, if it works in the network. So I'm going to do a demo, quite a quick demo of Payara Cloud. So before we go dive into it, so what we did is, as I said, we looked at how you configure, say, Payara Micro, which you can do, in a container on Kubernetes with MicroProfile config and all those sort of things, and all the steps you need to do that. We estimated that someone who knew what they're doing from scratch could maybe do it in a week to get it all set up. Everything, that's Kubernetes and everything. And we thought, well, let's take that Java EE model and actually, well, we could do that for you. So I'm going to basically show the basic deployment in Payara Cloud. So currently, this is a hosted service on Azure. So this is running on Azure Kubernetes service. But what we're building is effectively a Kubernetes native applications runtime. So as you log in, what you have are namespaces. So namespaces effectively correspond to logically to Kubernetes namespaces. So everything in the namespace can talk to each other through logical names rather than through DNS. And I have a demo namespace here for EclipseCon. And what I'm going to do is basically just upload a new Jakarta EE application. So if I just do upload, so I'm going to deploy. So I choose a WAR file. I open it, and I'm going to deploy it. So that was suspiciously quick. So what we've done is we have uploaded an application, and it is running on the cloud. So that application is basically can be configured. So under actions, what we do is when we take the application, we look at it from a Jakarta EE point of view, we see what's in it, and in this case, oh, hang on. Oh, sorry, I've uploaded the wrong application. That's my problem. Why, hence it was suspiciously quick. I want this application, which is a demo, a game demo, and upload that. So basically, when you upload, what it does is it inspects the application. It looks at all the Jakarta EE aspects of that application. It then creates infrastructure for the application and deploys it in the same way as you would on an application server. So as I said, what it does is it inspects the application. It looks at all the MicroProfile config properties that you have, and it exposes them so that you can edit the properties. It also, not shown here, but it also looks at persistence.xml, data source definitions, and exposes those that so that you can configure them if you need to for an external database. And you can also save it as a revision and then decide when you want to deploy that application or not. So it should be running, but who knows? So that's the actual application running. So it's a very simple application. You just put your name in, and it's a quiz, but it's just a demonstration to see that this is a JSF application where you can play games. And, can't do maths under pressure. So, and then within the Kubernetes native runtime, we can also do typical things you'd be able to do in an application server. So we obviously do monitoring, and we can do metrics on the application. You can get thread dumps. He says, demos never work. Oh, there we go. So you can monitor and see what's happening in the application. So it supports standard Jakarta EE up to web profile. Well, anything Payara Micro supports, which is web profile plus. So Payara Micro supports web profile plus concurrency, which will be web profile in Jakarta 10, and it also supports JMS clients and things that you would need in a container application. Okay. So let me switch back. So that was how quick it is if you take the concept of an application server to apply it onto public cloud. So under the covers, Payara Cloud is a Kubernetes native runtime. So this is running on Azure AKS at the minute. What it does is when you do that deployment, it basically takes that WAR file, as I said, it strips it down, it looks at what you've got in it, and it looks for deployable resources, and it exposes those to you to config. So there was a step, before where you could have just uploaded the WAR without running it, and then edited the config that you required, or put a properties file within the WAR file as you deploy it, and it'll find all those properties and expose them, so that as an application developer, you can change them if you need to, if you've got different sort of database connections and things. Alternatively, you could have a config source in your WAR file that went off and pulled them from some external configuration source. And then what it does once it's done that is it actually takes your WAR file. We have a container image which is layered up with the runtime, and then we just put a very small layer on top, which is just the WAR, build that into container image, create the pod definitions, load that into the AKS service, and then execute it and basically run. And then it also needs to go off to Azure and change all the API gateway inbound, all the ingress, so that you can actually access your application on the fly. It also then has to do DNS. So it sets up the DNS for you, it sets up an SSL certificate for you, and all those things. So it's actually building the whole infrastructure for you so that you can just concentrate on running the application. So it basically takes a lot of the things that currently now you would have to do. So if you were at building a normal application, then a lot of this stuff you would need to do beyond the deploy stage yourself. Or you need to run or build a platform or work for someone to build platform engineering for you. So Payara Cloud also has built CLI infrastructure for it. So as a command line, you can do it all by command line as well. And that means you can build continuous delivery pipelines that will take your Jakarta application, compile it, run it, and then deploy it onto a cloud infrastructure straight away. So for example, we have here just the command line at the top, how to get it, and then you go command line just to upload a WAR file. And we have a demo of GitHub Actions for doing that from GitHub Actions, so you can commit and deploy. Okay. So Payara Cloud at the minute is in a first version. So the goal really is ultimately is in that Q3 there is to build a Kubernetes native installable server so that you will be able to use it and run it in your own infrastructure. So basically you'll be able to take Payara Cloud and actually install it on top of K8s and have that Kubernetes native runtime and application server. So there's some work we still need to do. So it can actually deploy at the moment and deploy applications and run them and on different instance sizes. You can configure it. So it does everything that you would need to do to deploy. There's some bits that we're working on. First is clustering. Currently, you can't cluster sessions on it, so you can't do that. But that's pretty easy to do. And then rolling upgrades. At the minute, you can create new revisions, set the config, and then hit the deploy button when you're ready, and it'll reload the pod with the new definitions. But we're currently working on doing it so that the old one stays up, and then the new one comes up after. Currently, we're also only running on Azure AKS. And so at the end of next year, we'll be looking at AWS as well, and looking at other targets like Fargate and those sort of things. Okay. So next steps is if you want to use Payara Cloud, then it is actually a PaaS service at the moment. So it is available, and it is in GA version 1. So to summarize in my last 3 minutes, basically what we wanted to do is just rethink what an application server is and to actually go back to the basic principles of Jakarta EE, of the separation of your WAR file, and build a runtime on top of Kubernetes to make Kubernetes from a bit of a poor application server, if you like, to a good application server for Jakarta EE. So that is our compute infrastructure underneath. And do that in a different way. Now, Payara, we obviously support Payara Micro, which can get packaged into containers, and you can do it the other way. But I say we're building Payara Cloud to be that Kubernetes native runtime. So I have 7 minutes for questions. So any questions? Hopefully that's sort of just the idea was to change the way of thinking, to see if you could think from a Java EE perspective and what we could do. Sure, yeah. Ooh. I might need to give you the mic, hang on.
Yeah, maybe I can just
shout. Okay.
It's very easy for me. First, forgive me if I'm asking something obvious. Maybe I'm not really familiar with Payara.
There are no stupid questions.
So. I've been using application servers in the past. I've been using WebSphere Liberty. For example, one of the nice features I liked for my clients was the ability to configure container-managed security. So switch on some trust association interceptor in Liberty, or delegate to the container the integration with, I don't know, LDAP and Finagle for a single sign-on. So is this something that will be available in this environment? And the second question is, if I want to upscale my application to more instances and containers, should I then go to the Kubernetes console, or is something that this web interface will eventually provide me? So just to say, for a user who is not an expert, will this provide enough gears to be able to do most of the operativity, or would someone also need to learn Kubernetes?
So the goal is not to need to touch Kubernetes at all. So on the first one on security providers, basically the application, if it has packaged in it a Jakarta EE resource, so one of the, let's say, Jakarta security provider or something like that, then we can introspect the annotations for that and build and present them as a set of configurations that you can then modify. So you need to change the URLs and things. So if you had a security provider that was in modern Jakarta security, then we could do it. If it can or alternatively, if something's packaged in the application and you expose things through MicroProfile config, then yes, you could do that as well and load those in. On the scaling, yeah, you'll be able to scale from this. So at the moment, that's not there, but that's part of the work we're doing on the clustering side, is to have horizontal scaling. But it's easy for us to do because we just need to increase the number of pods. So but you wouldn't need to use Kubernetes to do that.
Thank you.
So, do you want the...
That's okay, actually. How do you do redeployment for new version of my board if I change some configuration? So I need to change the resources.
Okay, so you can go in and, let's say, it exposes as much config as it can find. You can just save that. So you can go in and edit the configuration and save it as a new version, and then, or you can upload a new WAR file if you want. And then at that point, once you've done that, you can hit deploy when you're ready, and it will recycle. Whereas the next version will run the first one, and then until the second one's up, and then switch all the ingress across.
Can it also preserve some of the resources?
Sorry?
Can it preserve some of the resources that were created?
Depends what they are. Such as?
I don't know.
Yeah, I mean, the model we're looking for is that we package as much, because Jakarta 10 and 9, you package as much as that resources within the application, and then we introspect the application. So if it's in there, then it would do it. Any more questions?
Yeah, maybe another one. So what I think we just saw is kind of remove the complexity of Kubernetes deployment or application provisioning and focus on the application development part. But I think there are some aspects that kind of mix in between these two. So you talked about the ingress controllers, for example. Is there a necessity for SSL configuration or something like that, which I do not see at the moment where the right configuration is. From the Kubernetes perspective, it's obviously a YAML file or something like that, but I think there might be some configurations that rely heavily on the implementation part of the application itself. So will there be some kind of configuration aspect on this kind of like MicroProfile is doing with the telemetry stuff, or will this be always on the Kubernetes side of definition or configuration?
It depends. I think it'll depend on what you want to configure. So obviously, if it's on AKS run by us, that's configured as how it should be. If it was in a Kubernetes in your data center, then if there was specific Kubernetes stuff that needed to be done, then it obviously probably they'd done by someone who knows that Kubernetes. But from an application perspective, as a developer, I think it'll depend on what that case was. I mean, is it something exposed in the application or something you would go into an application server console to do, then what this is running underneath is Payara Micro. So Payara Micro exposes a lot of those as properties anyway, so you'd be able to add properties files that will configure things like, which trust stores you use and things like that. If there was specific stuff like that, then we package that in the Payara Micro image, and you'd be able to do that. So it depends what those SSL things are.
Yeah, I think kind of the vendor-specific part on the Kubernetes implementation or the controllers you use, kind of the idea if you take a specific ingress controller that cuts off some parts of your URL or something like that, which is kind of the same thing we do on the application side with the webxm parameters, which is the kind of source root for the application. Where would be this configuration, or will it be configurable?
Well, Payara Micro at the minute, so will it be configurable? It depends. Like I say, it'll depend on specific what it is. Payara Micro at the minute can take variables and inject MicroProfile config variables into those variables. So if there's stuff in your web.xml or something that is variables, then it can inject MicroProfile config values into those. So you wouldn't have to edit your WAR file if you need to change URL paths, the security of URL paths, or anything like that. There's also actually in the console itself, it has rules for if you want to change the URL paths that are exposed by the application from the ingress side, but that's currently specific to AKS. Sorry, Azure Kubernetes service. So, but I say ideas like that are what we're trying to work with people to understand which bits that they would need to configure. But we haven't got like a Kubernetes native yet. It's just Azure Kubernetes Service native at the moment. Okay. Thank you.